Hi, geometry students. This is a lesson about three new vocab words: perpendicular lines, complementary angles, and supplementary angles. The first we're going to talk about is the word perpendicular, which you have seen before. So lines, rays, or segments that intersect at 90-degree angles or right angles are called perpendicular. So let's write that down. All right. So some examples of perpendicular lines or segments are these. We have line A and line B, and it's given that this is a right angle. We can say that A is perpendicular to B. That A represents line A. The upside down T tells us that it's perpendicular to line B. We could also have two line segments, the same little square in the corner. And here we'd say that segment DE is perpendicular to segment FE. All right. So one really important thing when you're looking at diagrams is to not assume that lines or line segments are perpendicular unless you are told. If it looks like it's perpendicular, you can't make that assumption in a proof or a problem. All right, our next definition is complementary angles. So complementary angles are two angles whose measures sum to 90 degrees. It is important that it's just two angles. So if I have a 10-degree angle and an 80-degree angle, they're complementary because together they add up to 90. But I wouldn't say that about a group of three angles that add up to 90 degrees. So let's look at some examples of complementary angles. If angle A is 40 degrees, and then I have an angle B that's 50 degrees, then A and B are complementary. So angle A and angle B are complementary angles. Similarly, if I have a right angle and I split it into two parts, so this is angle 1 and this is angle 2, even if I don't know what angle 1 and angle 2 are, I can see that they add up to 90. So I can say angle 1 and angle 2 are complementary angles. All right, our last vocab word is supplementary. Here. All right. So our last definition that supplementary angles underline that, sum to 180 degrees. But again, it's two angles, not more than that. So supplementary angles are two angles that sum to 180. They don't have to be adjacent. If they are adjacent, they're called a linear pair. They just have to have sums, measures that sum to 180. So an example is if I have angle J, that's 20 degrees, and angle K, that is 160, then angle J and angle K are supplementary. Or I could have a straight line. Here, angle 3 and angle 4 are supplementary because their measures add up to 180. So you're going to see complementary and supplementary angles coming up in algebra problems. And I'm going to do an example of one of those right now. So this is an example of an algebra problem. Let's say an angle is 3 times larger than its complement. What is the measure of the angle? So before I write an equation, I'm just going to do a quick sketch. So let's say the angle is x. Well, the other one's supposed to be smaller. The angle's complement has, this angle plus that angle has to be 90. So this one has to be 90 minus x, right? Because then if I added them together, I would get 90. Another way to think about that is to start off the 90-degree angle and say, okay, I know the two angles are complements. This one is x, so this one must be 90 minus x. Now what I also know is that x is 3 times larger than its complement. So I'm going to write the equation x equals 3 times the complement, which is 90 minus x. And now I can solve this by distributing. So x equals 3 times 90 minus 3x. X equals 270 minus 3x. I add 3x to both sides and I get 4x equals 270. So x equals 65. Uh-oh, let me just make sure. I don't think that's right. I think it's 67.5. 6, 7, yeah. Whoops. 67.5. So the original angle was 67.5. This would be 90 minus 67.5, which is 22.5. All right, I'm going to stop there, but we'll do more examples like that in class tomorrow. Thank you.